Hello everyone, Miss Sola here with geometry. Go ahead and take out your notebook, open up to your table of contents. Today is 1.6 deductive reasoning. So remember, inductive reasoning is all about finding a pattern to predict what comes next. Deductive reasoning, no patterns, just what are the facts? What facts lead me to a conclusion? Like a detective. 1.6 deductive reasoning. All right. So my deductive reasoning, I'm going to use facts. I'm going to use definitions and properties to form a logical argument. Use facts, definitions, and properties, like properties of a triangle, properties of a line, to make a logical argument. So thinking about what we talked about yesterday with my conditional statements, also, I've got kind of two laws that I can use with those if P, then Q things. So the law of detachment. To detach is like to separate, right? The law of detachment, to separate something. So this goes like this. I'm going to use blue. If P, then Q. P is true. So Q has to be true. So Q. For example, it's tricky. I don't know what day you're using this, but I'm going to just do my example anyways. If it's Monday, then Tuesday is next. It is Monday. So if it is Monday, then what has to be true? So to conclude, I can make a logical argument that Tuesday is next. Tuesday is the next day. Tuesday is tomorrow. If I charged my phone last night, then it has 100% battery right now. I charged my phone last night, so it's at 100%. If I drink water, then I will not have a headache. I drank water, so I will not get a headache. So this is just kind of a, if P then Q, the first part is true. If the first part did happen, then the second part will happen. That's the law of detachment, kind of separating the P and the Q. Next I've got, and this one's funny, sounds funny, but it makes a lot of sense. The law of syllogism. Syllogism, like that. The law of syllogism. And this one's kind of a path. This one takes a little bit of a journey. So stay with me here. So if hypothesis P, then conclusion Q. If P, then Q. Next sentence. If hypothesis Q, then conclusion R. So take a look at my journey here. If P, then Q, and if Q, then R. So what the law of syllogism tells us what we can do, and this could go on and on and on and on and on, but what this law of syllogism tells us to do, if P then Q and if Q then R, I can jump from P to R. If hypothesis P, then I can like skip Q because Q kind of relates them both. Then conclusion R. If hypothesis P, I can skip that orange, I can skip Q all the way to conclusion R. If these two are true, then I can jump from one to the next, the beginning all the way to the end. And like I said, this can go on if A then B, if B then C, if C then D, if D then E. So A then E. Like it can be as many statements as you want. I've got one more example for you using the law of syllogism here. So let's say if Janelle gets a job. If Janelle gets a job, then she'll get paid. Generally, that's the nature of a job. If you get a job, then you get paid. Now, if Janelle gets paid, then I know what she's going to do with her money. She's going to buy a car. She will buy a car. If Janelle gets a job, then she gets paid. If she gets paid, then she's going to buy a car. So we can kind of use the law of syllogism here to conclude if Janelle gets a job, then ultimately in the end of this story, what's going to happen? She's going to buy a car. She buys a car. If P, then jump all the way to the end of the story, R.